Hello. In this video, I would like to give you a brief update on the status of Piano as of November 2023. Piano originated in the late 1980s as an analytical program for aircraft project design. That is a story for another occasion. The full Piano can be used to generate complete aircraft definitions from scratch and covers a wide spectrum of technical capabilities. The full Piano is also called Piano5. I will use both names interchangeably. The 5 is simply an implementation number and has been stable for at least a decade. Piano-X is a separate tool and has a reduced set of capabilities. It can be used to run prepared and licensed aircraft models, but not to generate them, and its definition files cannot be modified. The Piano-X program is free to download, but only contains a few examples. Its full aircraft database is not free. Most Piano-X users focus primarily on aircraft environmental emissions. They are able to extract all the information they need easily and without having to have any specialist aeronautical knowledge. If you have looked at any of the previous lectures, you will know that some of the tasks that Piano5 is capable of doing can be quite complex. Because of that, the option of using Piano5 seems, at first, a bit scary to a non-aeronautical user. In reality, provided you don't intend to try and design aircraft, it is straightforward. Anything that you do in Piano-X can also be done even better in the full Piano. The interface is clean and all you need to learn is which menus to pull down. That is just a quick familiarization exercise and we will go through all of it in another video. Let me now outline the current state and direction of Piano. Piano remains, as before, a commercial product. It is, as before, only available through License Limited. Nothing has changed there. Strategically, my primary focus is on working with a few key entities in the industry towards opening Piano up as a shared global resource. Time alone will tell if that will be possible. There are, however, many very good reasons to try and achieve that goal. Piano users range from aeronautical engineers doing aircraft project sizing and performance predictions, through national and global institutions doing regulatory or environmental work, to executives in big tech enabling cooperations between global teams. All of these people can work with the same numbers using a single program whose contributions were acknowledged by the EPA in the United States Federal Register. With a database of more than 600 aircraft, compiled over a third of a century. All of it generated independently of any outside interests, be they institutional, corporate, political, or anything else. This background makes the full Piano a unique common reference. Every one of its assumptions is always transparent across the board. Everybody can check any aircraft model and adjust it as needed to make it consistent with any other model, whoever its developer might be, in a seamless environment that is accessible to both expert and casual users. That is the heart of the matter: genuine transparency and consistency in a universal physics-based analytical tool, explicitly using fundamental design-level technical modeling of aircraft characteristics and performance. These are solid foundations on which to base global policies and legislation. They enable the open, public quantification of all fuel burn calculations under any realistic operational scenarios or sets of assumptions. They can establish credibility with engineers, regulators, and the public. There is no such thing as science without technical transparency. Fuel burns whose basic derivations are opaque or effectively withheld cannot be used in regulatory policies. At the moment, an intensely competitive struggle is taking place between several stakeholders in aviation emissions. They include air transport associations and civil aviation organizations. In this great game, the objective is to capture a perceived market for systems that claim to assess aviation emissions and to decide their definition and quantification. Yet none of these players applies essential aircraft design modeling methodologies to calculate the underlying fuel burns in the way that any aircraft manufacturer would in reality. To put it simply, everybody in this game needs to first and foremost derive performance numbers. Piano does do just that. It has been doing it successfully, consistently and quietly in the background since the 1990s, since before the original Coronair database with the UK DTI. In this series of lectures I have given detailed descriptions of how this process has worked and continues to work. Lectures 6, 8 and 9 are examples of the development, evolution and accurate calibration of specific modern aircraft models, all derived from scratch. Piano and its easily adjustable database can, if they are opened up, transform the entire field for the better. Knowing accurately how every civil aircraft performs is a prerequisite if we are going to build up a useful picture of how the vital planet-wide system that we call aviation really behaves. That kind of knowledge does not in any way enable any competitor to replicate someone else's technology or design. Despite that, a pernicious culture of secrecy prevails in the aviation industry. This is deeply damaging, and not just in terms of emissions. Technical education suffers, specialist know-how is lost, and academic research is kept in the dark, for no reason other than to retain control of the few carefully chosen numbers that manufacturers release for marketing purposes. The next year or two will likely determine whether Piano's unique potential to offer de facto transparency to all is embraced by key players and used to benefit all through consistent and open regulatory practices. Influential aviation organizations such as IATA, ICAO and ICAIA, which is the Manufacturers Association, are all stakeholders in aviation emissions with perfectly legitimate interests. They all include professionals who understand the technicalities of the numbers game that is playing out. These technicalities matter. They matter at a very real level that affects all of humankind. Their proper quantification, meaning the submission of fuel burn numbers to public scrutiny, is missing. It is needed. Let me leave you with this thought. As AI tools take center stage and are seen to be very capable of misleading, trust in the consistency of their underlying training data has become a global concern. Failing to use transparent physics-based modeling to underpin such enormously powerful tools with verifiable engineering information would be a very consequential error. Thank you very much for listening.